Intro. Hello everyone, and welcome back to our channel. Today, we're diving into a topic that's becoming increasingly crucial in the world of artificial intelligence and machine learning: building a seamless end-to-end AI workflow. If you've ever wondered how data transitions from raw ingestion to production-ready model deployment, you're in the right place. In this video, we'll walk you through each step, discussing the best practices and tools you can use along the way to ensure a smooth and efficient process. So, whether you're a seasoned data scientist or just starting out in the AI space, there's something here for you. Let's get started. Section 1: Understanding the AI workflow. First, let's define what we mean by an end-to-end AI workflow. In essence, an AI workflow consists of several interconnected stages, starting from data ingestion and pre-processing, moving on to model training and validation, and finally reaching deployment and monitoring in production. Each of these stages is critical, and a hiccup in any one of them can lead to inefficiencies, inaccuracies, or even project failure. Imagine you're building a machine learning model to predict customer churn for a subscription service. The first step begins with data ingestion, where you gather all relevant data points from multiple sources. This includes customer demographics, engagement metrics, transaction histories, and even customer feedback. The quality and relevance of your data will significantly impact the performance of your model. Section 2: Data Ingestion. Let's take a closer look at data ingestion. In this phase, you need to aggregate data from various sources. This could involve pulling in data from databases, APIs, CSV files, or even real-time streaming data. The goal here is to ensure that you have a comprehensive dataset to work with. One of the key tools that can facilitate data ingestion is Apache Kafka. Kafka allows you to handle real-time data streams, making it easier to collect data as it comes in. Alternatively, if you're working with structured data, tools like Apache Scoop can be useful for transferring data between Hadoop and relational databases. Remember that data quality is paramount. You need to not only collect the data but also ensure it's clean and structured. This brings us to the next phase: data preprocessing. Section 3: Data preprocessing. Data preprocessing is where you refine your data. This includes cleaning, transforming, and normalizing your dataset to make it suitable for training a machine learning model. It's an essential step because even the best algorithms won't perform well on poorly prepared data. During preprocessing, you might encounter missing values, outliers, or inconsistent data. Techniques such as imputation can help fill in missing values, while normalization ensures that different features are on a comparable scale. This can involve scaling numerical features or encoding categorical variables, which is where tools like Pandas and Python come in handy. Another important aspect of preprocessing is feature engineering. This involves creating new features that can provide more insight to the model. For instance, if you're analyzing customer behavior, creating features based on user engagement over time might reveal patterns that are critical for prediction. Section 4: Model Selection and Training. Once your data is prepared, it's time for model selection and training. This is where you will choose the algorithm that best fits your problem. The choice of model can depend on various factors, including the nature of your data and the specific requirements of your project. Common algorithms include decision trees, support vector machines, and neural networks. Each has its strengths and weaknesses, so it's vital to understand their differences. For example, decision trees are easy to interpret but may overfit, while neural networks can capture complex patterns but require more data and computational power. Once you've chosen your model, the next step is training. This involves feeding your prepared dataset into the model and adjusting its parameters to minimize error. Here, frameworks like TensorFlow or PyTorch can be invaluable, as they provide the necessary tools to build, train, and tune models efficiently. During training, it's crucial to monitor performance metrics. Common metrics include accuracy, precision, recall, and F1 score. Utilizing cross-validation can also help ensure that your model generalizes well to unseen data. Section 5: Model Validation and Hyperparameter Tuning. After training your model, you must validate its performance. This is where you test your model on a separate dataset that it hasn't seen before. The goal is to assess how well your model performs in a real-world scenario. Hyperparameter tuning is also a critical part of this phase. Hyperparameters are the settings that you configure before training your model, such as learning rate, batch size, and the number of epochs. Tools like Grid Search CV or Randomized Search CV can help automate the process of finding the optimal hyperparameters for your model. Once you've validated your model and fine-tuned it, it's time to move on to the next stage, model deployment. Section 6, Model Deployment. Model deployment is where things get exciting. You've trained a model that performs well, and now it's time to put it into production so that it can make predictions on new data. There are various strategies for deploying machine learning models, including batch processing, real-time inference, or even deploying via APIs. One popular method is using containerization technologies like Docker. Docker allows you to package your model along with its dependencies into a container, ensuring that it runs consistently across different environments. Additionally, services like Kubernetes can help with orchestration, allowing you to manage your containers at scale. Another option is to utilize cloud services such as AWS SageMaker, Google AI Platform, or Azure Machine Learning. These platforms provide robust tools for deploying and managing AI models in production, making it easier to scale and monitor performance. Section 7, Monitoring and Maintenance. Deployment isn't the end of the road, it's crucial to monitor your model's performance continuously. This helps identify any drift in model accuracy, which can occur due to changes in data patterns over time. Implementing monitoring tools can help you track metrics and alert you to any significant changes in performance. Real-world scenarios are often unpredictable, so it's essential to have a plan in place for retraining your model as new data comes in. This could include setting up automated workflows that regularly update the model with fresh data, ensuring it remains relevant and accurate. Additionally, collecting feedback from users can provide insights into how well your model is performing in practice. This feedback can be invaluable for identifying areas for improvement, guiding future iterations of your workflow. Section 8, Best Practices for a Seamless Workflow. As we wrap up our discussion, let's highlight some best practices for building a seamless end-to-end AI workflow. Firstly, prioritize data quality throughout the entire process. High-quality data is the foundation of an effective AI model. Secondly, automate wherever possible. From data ingestion to model monitoring, automation can save time and reduce human error. Thirdly, ensure collaboration across teams. AI projects often involve data engineers, data scientists, and domain experts. Communication and collaboration are key to creating a successful workflow. Lastly, embrace a culture of experimentation. AI is an evolving field, and being open to testing new ideas and approaches can lead to innovative solutions. Conclusion. To sum up, building a seamless end-to-end AI workflow involves careful planning and execution at each stage, from data ingestion and pre-processing to model deployment and monitoring. By following best practices and leveraging the right tools, you can create a robust workflow that not only meets your immediate needs but also adapts to future challenges. Thank you for watching. If you found this video helpful, please like, subscribe, and hit the notification bell for more content on AI and machine learning. We'd love to hear your thoughts or experiences with building AI workflows in the comments below. Until next time, keep innovating, and see you in the next video.